Right. In this video, we're gonna focus on correlation coefficient. The first video we treated the introduction to coefficients, that is correlation coefficient. Okay, we defined correlation coefficient. So in this video, we are going to focus on the methods of calculating correlation coefficient. Of course, we have other methods, but in this video, I'm going to focus on the two major methods of calculating coefficient. The first one here is said to be Pearson product moment correlation coefficients. This statement, okay. While the second one here is said to be Spearman's ranking correlation coefficients. This statement. Okay, the first method here we have to consider is Pearson product moment correlation coefficient. You can also call this guy here PPMCC. Please take note. So the second one here is said to be Spearman's ranking correlation. You can also call this guy here, please take note, ranking correlation. Please take note, okay. Well, this is what you should understand here, that in solving this correlation here, either using Pearson product moment or using Spearman's ranking correlation here, we have formula for it. That means each of them have their various formula, okay. So if I'm asked to find Spearman's Pearson product moment correlation, I have to use the formula for Pearson product moment correlation. And if I'm asked to calculate for Spearman's ranking correlation, I have to use the formula for Spearman's ranking correlation. But sometimes the method might not be specific. For example, they might not tell you guys to use maybe Pearson or Spearman's ranking or ranking correlation. So whenever the method is not specific, it's unknown to us, we always use Pearson's product moment correlation. Please listen to me carefully. Whenever the product is unknown, that means whenever the product is not specific in terms of calculating correlation, we use Pearson product moment correlation. Please take note. So now let's focus on the first one there, that is Pearson product moment correlation, okay. So we are focusing on the first one here. Okay, the formula for Pearson product moment correlation is said to be that the formula that is rho is equal to plus n of sum of sy minus sum of s sum of y over square root of n sum of s all squared minus sum of s all squared into n sum of y squared minus sum of y all squared. Please take note. So what does it mean here? It means that when I'm giving the value of s and y, that means I can find s times y, which is this one here. So the sum of it there will give us this value. So when you sum the part of s, it will give you sum of s. When you total the part of y, it will give you sum of y. So you have to maybe generate s square, and when you total s square, it will give you this guy here. So this guy here is just the square of the sum of this guy here. Please take note. So you have to generate y square if it's not given to you in the table, and when you sum it, you get this you have this part. So this is said to be sum of y all square. So we already have sum of y here. You square it. So this m here is the frequency of s and y. Please take note. So let's solve a question here to understand this topic properly and create build confidence in terms of this topic. Okay, let's solve a question here. Question 1. Let's say compute okay, class. We have this table here. So let's remember in this table here, what we only have is s and y. So we don't have sy. That means you have to create sy because there's sy in this particular formula here. Please take note. And we have to create s square from this table here. Okay, because of this formula here, we have a s square here, and we have to create y square from the table. That means because of this. Please take note. So let's try to recreate, or let's try to sketch this table. Let's try to resketch the table in order to provide the available parameters. Okay, so class, let's try to okay, I'm coming. Okay, class, let's try to resketch this here. Of course, I'm going to have this to be something like this. This is my s, this is my y. Okay, this is my sy, this is my s squared, this my y squared. Please take note. So I'm trying to create the table depending on the formula. Okay, I'm creating the table depending on the formula, because if I have sy, that is this one here, the sum of it will give us sum of sy. If I have s squared, the sum of it will give us sum of s squared. If I have y squared here, the sum of it, the total of it will give us what? Sum of y squared. Please take note. So the values are 2, 4, the values of s, and 6. But the values of y are 1, 9, and 7. So let's try to impute the values here. To find sy, that means 2 times 1, sy will be this times this. So I'm going to have this to be 2. That means this times this will give us sy, that will be 36. This times this, that is 6 times 7, will give us sy. Okay, when you punch your calculator, that means 6 times 7, we have that to be 6 times 7, we have that to be 42. That is 42. So the next thing here is for us to get s squared. So for s squared, that means you only square this part here, all the s. So square all the s. This will be 4, 16, 36. Now square all the y. For y square, square all the y. This will be 1. When you square this, you have 1. Square this, you have 81. Square this, you have 49. So the next thing here is for us to get the sum of s. The sum of s means the total of s. That is sum of s here. Sorry for that. The sum of s means the total of s. That is sum of s. Let's get the total of s here, class. To get the total of s, we say is 2 plus 4 plus 6. So the answer to this is 12. So to get the sum of y, that means we have 1 plus 9 plus 7. We have this to be sum of this of y is 17. To get the sum of sy, we have this to be 2 plus 36 plus 42. Okay, 2 plus 36 plus 42 is 80. We have this to be 80. To get the sum of s squared, that is 4 plus, that is 4 plus 16 plus 36. We have this to be 56. This is 56. So to get the sum of y squared, we say 1 plus 81 plus 49. We have the answer to be 131. Okay, now let's try to impute the values. Okay, imputing the values into this formula, that is into the formula of Pearson product moment correlation formula. That means R is equal to class n sum of sy minus sum of s sum of y over square root of n sum of s squared minus sum of s all squared into n sum of y squared minus sum of y all squared. Please take note. So let's impute the values, class. I'm going to impute the sum of sy, but before them, let's know what m is. M is the frequency of sy. That is the number. How many number is sy here? We have this to be 1, 2, 3. So that means m is equal to 3. So our arrow here is said to be 3 into sum of sy in the table there. Sum of sy is said to be 80. So we have this to be 80 minus sum of s in the table there is said to be, sum of s is 12. We have this to be 12. Sum of y, we are using this formula here. Please take note, we are using this formula here. Sum of y, sum of y, sum of s. Okay, sum of y is 17. That is 17. Please take note. All divide by square root of 3 into sum of s square is given to us as 56. That is 56 minus sum of s is already 12. You square the value from the formula. Okay, now into 3 into sum of y square is 131 minus sum of s, sum of y square is 17 all square. Please take note. So the next thing we are going to do here is to evaluate. We have to be very, very careful. Okay, now let's evaluate carefully. Evaluating here, let me clean this part first. Evaluating here, I have to multiply. That means our correlation here using spare Pearson product moment said to be equal to 3 times 80 gave us 240 minus 12 times 17 gave us 204. Please take note. Over square root of 3 times 56 is 168 minus, please take note, 12 all square will give us 144. Okay, into 3 times 131 is 393 minus 17 all square, that is 17 times 17 give us 289. So let's evaluate totally here. So our arrow here will be equal to plus 240, that is 240 minus 204, that is going to be 36 divided by square root of 168 minus 144, that is 24 times 393 minus 289, that is 104. Please take note. So we are going to have this to be, class, we are going to have this to be equal to 36 divided by 24 times 104. So we have square root of 2496. So now let's get the total answer of this. To get the total answer of this, let me just clean this part here. So we have to say something like this: square root of 2496 first before we divide that result there. Okay, please, in case you have not subscribed to the YouTube channel, to get the full video on correlation and other topic on statistics, all you just have to do is to hit the subscribe button to get most of our videos. Okay, so lastly here we have this to be arrow will be equal to plus square root of square root of 2496. Square root of that is said to be this is said to be 36 divided by 2 2049.95 sorry 49.9599123 that is I have this to be approximating to 4 decimal places. I have this to be 6 0 0. Okay, so that means I will be equal to, we approximated it to 4 decimal places for accuracy. That is the reason for your 4-figure table. Okay, now that means lastly here 36 divide by 49.9600. The answer is said to be 0.7206. okay, now to interpret this here, we see that this is said to be this correlation is greater than 0.5, so we call it strong positive correlation. This is said to be strong positive correlation. Strong is strong positive correlation. Please take note of this. Okay, this is said to be strong positive correlation. This statement is said to be strong positive correlation. So in case you have not gotten our video in terms of interpretation of correlation, that is the degree of correlation, how to interpret that, all you just have to do is to search on the YouTube channel to get the video on how to interpret correlation. Okay, thank you so much.